Good evening, students. Welcome to the Toppr classes of JEE Advanced Preparation. Today, our topic is for physics, ray optics and wave optics. Let's start with the questions directly. So, our first question for today is, I'm reading, two plane mirrors A and B are aligned parallel to each other as shown in the figure. A light ray is incident at an angle 30 degree at a point just inside one end of A. The plane of incidence coincides with the plane of the figure. The maximum number of times the ray undergoes reflection, including the first one, before it emerges out, we have to calculate. It came in the IIT 2002. Now see, this question is a relatively very simple question in the sense this actually does not have much optical theory into it, but we have to apply the geometrical principles. If you see, like, what is the question? This distance is given, A and B are the two mirrors, the length of the two mirrors are given, the distance between them is 0.2, right? And the angle of incidence is 30 degree. Now, when this ray is the angle of incidence is 30 degree, the angle of reflection will also be 30 degree, right? Again, at this point, it will undergo another reflection like this, again 30 degree. This angle is again 30 degree. Again, it will reflect like this. So, this angle is again 30 degree. So, there will be a number of consecutive reflections, one after the other, because of this plane mirrors, plane parallel mirrors. So see, the question is the maximum number of times a ray undergoes reflection. Now see, the ray is undergoing reflection 1, 2, 3, 4, 5, like this, all this number of times. If you see properly, this distance, so the ray is undergoing reflection and also changing its direction at every possible points like this, which are separated by this distance. This is the distance which all the points are separated. So if we can calculate the, say this is x. So if you can calculate the length of this x and we divide the whole length of the mirror, that is 2 root 3 meter, by this x, we will be getting the number of reflections, right? So let us find out what is x. Now, if you see from this triangle, x is nothing but this x, this is the x, right? And this distance is given 0.2, right? And this angle is 30. So we can write tan of 30 equals to, this angle is 30. So tan of 30 is x divided by this length, which is 0.2, equal to x divided by this. So x is nothing but 0.2 into tan of 30. Tan of 30 is nothing but, so it is 0.2 root 3, right? Now this is x. So how many number of times the ray will undergo reflection? As we have derived, it is nothing but the length of the mirror divided by the x. So number of reflection we will get, what we will get, let us find out here. N will be equal to 2 root 3 divided by x is 0.2 divided by root 3, which becomes 2 by root 2 becomes 10, root 3, it goes up, in the numerator becomes 3, it is 30. So number of reflections will be 30, and this is the answer. Okay? Let's move on to the next question. Fine. Let us read this question. A container is filled with filled with water whose refractive index mu is given 1.33 up to a height of 33.25 centimeter. You can see this height is 33.25 centimeter. A concave mirror is placed 15 centimeter above the water level. Above the water level, the concave mirror is placed. This length is actually the 15 centimeter. Though they have shown here, we don't take the mirror to be of finite height or finite length, right? So this is nothing but 15 centimeter. And the image of an object placed at the bottom is formed 25 centimeter below the water level. So what is happening? That is, the object is placed at the bottom. So this is the object and the image is formed here. This is the image, right? Then we have to find the focal length of the mirror. Different pen, different color. Okay, fine. So there is a feedback. I have to change the color of the pen. Let me use then black and blue and red. Red will be the best color, isn't it? Okay, now it is visible. Fine. Now see, so what is happening? The object is placed at the bottom and the image is at this point, right? Now, the mirror, the concave mirror is placed in air. Now, the object distance, the actual object distance is this is the actual object distance, but part of it is inside water. So definitely this depth, this height will not come as the original height, but the apparent depth. So this is the real depth, right? Looking above the water, we will not get the real depth, we will get the apparent depth, isn't it? Say this is our apparent depth, right? Then what will happen? The object distance will be this 15 plus this apparent depth, right? Similarly, the image distance will also be, say, this 25 centimeter is the real depth of the image, right? So similarly, if you calculate the apparent depth of the image, it will be somewhere here, right? Then the apparent depth of the image will be 15 plus this apparent depth, right? So let us first calculate the the object distance and the image distance, considering the apparent depth of the object and the image. So we have been given this. Now let us try to see this real depth for the object. Say if it is 33.25, so apparent depth of the object will be 33.25 divided by mu, that is 1.33. If you calculate, it will come to 25 centimeter, right? So the actual u will be nothing but 15 plus this apparent depth, that is 25. So the object will somewhere like this, 15 plus 25, and having a minus sign before, because the object distance is always measured in the opposite side of the measurement of light. So it is minus, so it will be minus 40 centimeter. Similarly, we have to calculate the image, the apparent depth of the image, right? So just use this. For apparent depth of the image, if you remember, the image is at a 25 centimeter. So the apparent depth of the image is 25 divided by 1.33, right? If you calculate, it will come nearly something like 18 centimeters, something like that, right? So the image distance will be, right, if you go to the previous slide, is nothing but 15. This length we have to consider plus the apparent depth that we have considered, that we have found 18, is nothing but 15 plus 18. Again we are putting minus sign here. It is coming to somewhat 33, right? Now to find out the focal length of the mirror, we have to use the mirror formula, that is 1 by f equals to 1 by u plus 1 by v. It is nothing but minus that is 40 into 33 divided by 40 plus 33 minus, it will come nearly around minus 20 centimeter. It will nearly come around minus 20 centimeter. That you can calculate. So the answer will be C. Once again, I will be repeating the basic concept. So what we are doing, there is a concave mirror, right? The object is the bottom of this cylinder and image is this, but as we are using it in the mirror formula to find out the focal length. So all these theories need to be remembered while solving, like whenever there is a liquid or any substance whose mu is not 1, right, and we are looking the substance from outside, so we have to consider the apparent depth. Understand? Fine. We are moving on to the next problem. We'll try to solve as many problems. Third problem. A diverging beam of light from a point source S having divergence angle alpha, so this is a divergence angle, falls symmetrically on a glass slab. See, symmetrically it is falling. So this is also I, this is also I. As shown, the angles of incidence of the two extreme rays are equal, right? If the thickness of the glass slab is T and its refractive index is mu, then divergence angle of the emergent beam is, right? So this thickness is given T and the refractive index is mu, right? We have to find the divergence angle. Divergence angle means the angle with which the ray is coming out, right? That angle. Now see, if we try to find out what is happening, say this is the source of light and this angle is angle alpha. The angle of incidence at these 2 points is I and this is I. Now, when the light is traveling from a rarer medium to the denser medium, it will deviate like this, it will refract like this. But here, as the angle of incidence is same, the angle of refraction, say R, will also be same, right? Now, this ray of light, when it will fall on a glass slab on a parallel, will be equal to the angle of incidence. So what we can see, like this ray, if we go to the previous slide, if we draw similarly, and finally when the rays are emerging out, they are coming out at an angle of I. They are coming out at an angle of I. So if these are I, if you produce it backwards, right, these rays will be parallel to these rays, right? So they will behave as a similar triangles. So this angle is nothing but alpha only. That is the angle with which the source is diverging the beam. So this angle of divergence is equal to this angle alpha. If you see, if this is I, if you produce it backward, this is nothing but alpha. This angle is nothing but alpha. Clear? So the answer will be nothing but alpha. So why the thickness T and mu are given is only to confuse you. We would have used T and mu if the glass slab, if the opposite sides of the glass slab was not parallel but something else. Clear? Then we would have used these variables, right? Next problem. This is a very interesting problem. We have to study the graph. The graph shows the relationship between the object distance u and the image distance v for a equiconvex lens. The focal length of the convex lens we have to find out. Now see, one thing if you notice, the object distance as it is negative, it is plotted in the opposite direction of the x-axis, in the negative direction of the x-axis. And image distance in a equiconvex lens, right, in a equiconvex lens, this is the u asymptotes. So, and as it is a curve, every point, if we can measure every point, we can find out a pair of u and v. So every point will give rise to a pair of u and v. But from this graph, it will become very difficult to note every point and mark. But there is one point which is marked. See this. If you see, so when u equals to minus 10, v is 10. Now, when at what position of the object do you think the image will be just exactly opposite to it and exactly at the same distance from the lens? That is nothing but when the object, if you remember, the object is just at the this is the center of curvature, right? And when this object distance is at r, as r is the radius of curvature, is nothing but twice the focal length, then the image is formed just at the same distance, right? The image is formed just at the same distance. So we can say the object distance is r, is minus r, and the image distance is r, right? So we can say r is nothing but 10 centimeter. And we know focus f is nothing but half that. So f will be nothing but 5 centimeter. This is one of the approach. Otherwise, this is the purely the physical approach where you can visualize what is happening. Otherwise, if you just want to put the formula, then also you can find, right? This is a lens. So the lens formula is nothing but 1 by f equal to 1 by v minus 1 by u. So by putting the value, you can find centimeter. But it is not a so simple problem. We also need to calculate, we need to find out the error into finding the focal length. Why? Because when actually this kind of experiments is done, some error is inherently incorporated because of the measurement, right? Because all these lengths are, see, what is the least difference? The least count here is 1 millimeter. The least count is equal to 1 millimeter, which is nothing but 0.1 centimeter. So, while measuring U and V, there can be a that is, what should I say, the error in measuring U and V will be maximum will be 0.1 centimeter. So, we can write del U or del V equals to 0.1 centimeter. What are del U and del V? The error which is incorporated in measuring U and V. So, if there is error incorporated in measuring U and V, there must be, while calculating the focal length, there will be some error into it. We have to find out that error so that we get the final answer, right? So, let us try to find out. If this is the lens formula, you know by error analysis what comes, that if del f is the error incorporated into finding the focal length, del f by f square will be del v by v square plus del u by u square. You must remember that while calculating errors, the errors don't get subtracted, it is always appended. So, we will only use a plus sign. So, del f we have to find out, f we have already calculated 5, so it is 5 square. Del v equals to, it's in del v is equal to 0.1, it is 0.1 centimeter del v and del u, and v is 10, so v square equal to 10 square. This also 0.1 by 10 square, right? So, it is nothing but 0.2 by 100, right? This is del f by, and this is 25. So, del f will be 0.2 into 25 by 100. If you cancel, this will become 4, right? 0.2 by 4 is nothing but 0.05 centimeter. So, this 0.05 centimeter of error will be incorporated while measuring the focal length of the system. So, finally, the answer will be, our focal length is 5 centimeter and the error is 0.05 centimeter. The answer will be number C. If you see, focus, this is f and this is del f. So, our answer is number C. Okay. Look at it. We'll go to the next problem. Fine. Let us move on to the next problem. Okay. Now, say this is a question from the instruments, some optical instruments. Let us read it. The focal lengths of the objective and the eyepiece of a compound microscope are 2 centimeter and 3 centimeter. So, objective, so we can write this is FO and this is eyepiece FE. The distance between the objective and the eyepiece is 15 centimeter. The final image formed by the eyepiece is at infinity. Now, what does this say? When the final image formed by the eyepiece is at infinity, right, the object distance of the object and the eyepiece must be the focal length, then only the image will be formed at the infinity. right? The two lenses are thin. The distances in centimeter of the object and the image produced means we have to find out the object distance and the image distance produced by the objective lens respectively, right? Let us see. This is a diagram. If you remember a compound microscope, the objective is shorter than the eyepiece. Its focal length is also shorter. What I was talking about, the object, suppose this is the object will form a real image by the objective and fall in such a position that it will behave as a real object for the eyepiece. Now the final image is at infinity. When the final image is at infinity, then what does this mean? It means that this image from the objective, which is behaving as an object for the eyepiece, is lying just at the focal length of the eyepiece, isn't it? Then now this focal length, if you remember, is 3 centimeter. So this distance must be 3 centimeter, right? And the distance between the two lenses is given 15 centimeter. So finally, the distance between the objective and this image is 12 centimeter, and that is nothing but the image distance, right, of the objective lens, right, the image distance. So this is 12 centimeter. So we can write image distance by the objective length is 12 centimeter. We also have to find out the object distance, right? We have to find focal length is already we know. Focal length equal to 2 centimeter. All are positive, right? For focal length and image distance, all are positive as it is a convex lens. So, so this will be what? 1 by v, 1 by f equal to 1 by v minus 1 by u. If we add the suffix here, if u comes this side, 1 by u0 equals to 1 by v0 minus 1 by f0. 1 by v0 if you calculate, this is 12, this is 6, it will be minus 5 by 12. So that is u0 equal to minus 12 by 5 which is minus 2.4 centimeter. Let us see what are the answers. We have to find out the image. We have to find out the distances in centimeter of the object, which is 2.4, right? And the image produced by the distances in centimeter of the object and the image produced by the objective. But 2.4 is right, so this 2 will be the plausible answers, but this is 15, so it will be not. The answer is number A. So number A is the answer, as the object distance is 2.4 centimeter and the image distance by the objective lens is 12 centimeter. Clear? So in this problem, what you need to remember is that, like when it will be stated that the image is at infinity, it means the final image or the object of the eyepiece must lie at a distance of the focal length. Then only it will form an image which is at the infinity. Understand? Shall we move on to the next question? Okay, now there will be few questions where the MCQs with one or more than one correct answers, right? We'll be having one or more than one correct answers. Let us try to see. A double convex lens of refractive index mu1 is immersed in a liquid of refractive index mu2, right? This is mu1 and this is mu2. Mu2, so this is mu2 also. The lens will act as diverging, diverging, converging, converging, some conditions are given. How can we find out? One thing, if you can remember, just memorize that the refractive index of the lens, if it is greater than the refractive index of the surrounding, it will be a converging lens. And whereas the refractive index of the lens is lesser than the refractive index of the surrounding, it will be a diverging lens, which are means diverging lens if mu1 is less than the mu2, because this will be less than this, and converging lens when mu1 is greater than mu2. This will be the answers. This you can just remember or memorize, but how to actually find them? See, if you remember the lens maker's formula says that 1 by f equals to the, in this case, 1 by f equals to mu1 by mu2, that is the refractive index of the lens divided by the refractive index of the surrounding, right? So, in this case it will be mu1 minus 1 divided by 1 by R1 minus 1 by R2, right? Now, it is said it is a biconvex lens, right? It's a double convex lens, fine. So, for double convex, if you remember, this is refracting side 1, this is refracting side 2. So, this is nothing but R1 and this is nothing but R2. We measure R1 like this and we measure R2 like this. So, R1 is positive, R2 is negative, right? If R1 is positive, R2 is negative, so minus of minus, so R1 is positive, R2 negative, there is a negative. So, this becomes minus of minus becomes plus, this whole thing becomes positive, right? So, the sign of the f of the focal length, or it means, sign means the nature of the lens will be dependent on the sign of f, which is dependent on the sign of this thing, right, whether it will be positive or negative, because this is positive. Now see, if we analyze this thing, if mu1 is this one here we have considered, and this is mu2. If mu1 is greater than mu2, then only this portion is more than 1. So, this is positive. So, if it is positive, it means focal length is then positive. Focal length positive means it's a convex lens, means it's a converging lens. So, it will be a converging lens when mu1 is greater than mu2. Similarly, when mu1 is less than mu2, then this is a fraction. So, fraction minus 1, this is the negative quantity. So, negative quantity means the focal length is negative. Focal length negative means it is a diverging lens. The diverging lens when mu1 is less than mu2. What we have done? Diverging lens when mu1 is less than mu2, and converging lens when mu1 is greater than mu2. Okay? But so this way you have to approach a problem or solve a problem. Don't memorize the things, right? Let us see what. A beam of light consisting of red, green, and blue colors is incident on a right angle prism. Right. The refractive index of the material of the prism for the above red, green, and blue. So these are the refractive index. So this is mu r, green and blue respectively. The prism, what will happen? Right. Now see, when three colors are incident like this, they will enter like this. Right. Let me do one thing. Let me erase this portion. Let me draw with the exact the color. Blue. So blue will enter like this. Then green. Green will enter like this. And red. Red will enter like this. For all these, what will be the, we don't draw with black. What will be the incident angle? The incident angle for all will be nothing but 45 degree. So all these angles will be 45 degree. Now, you know, if the angle of incidence is more than the critical angle of reflection, then what happens? The rays undergo total internal reflection. TIR. Now, how to find whether the critical angle is more than or not? Let us try to find out. See, you know, I'm writing it here. You know, 47, it is given. Fine. Sine of critical angle, yes, 1 by mu, 1.44. Now, I say 45 degree, right? For 45 degree, sine of 45 1 by 1.41. Okay, sine of 45 is 1.41. Then see, the thing is that if we write the sine of critical angle is 1 by mu, these are the 1.39, 1.44, 1.47. 1.39 is greater than 1.44 is greater than 1.47. 1.39 is a sine of is the critical angle. From this you can find out the critical angle of red. From this you can find out the critical angle of green, and this is for blue. Now see, 45 is 1.41, is just above 1.44. So what does this mean? That is, the angle of incidence 45 is more than the critical angle of, this is for green, this is for green, and this is for blue. Blue, let me just, blue I have drawn. Let me draw for green. What happened? Right? But what for red? For red, 1.39, right? It proves this angle of incidence is more than, this critical angle is more than 45 degree. So red will not suffer TIR. So red will suffer refraction, and red light will come out from this surface. So finally, blue. Let us move on. Okay. Now this is a question from the wave optics. We are doing with ray optics, we have to do something from the wave optics also. In a double slit experiment, that is interference, Young's double slit experiment, instead of taking slits of equal width, one slit is made twice the wide as the other. Then in the interference pattern, what will happen? The intensities of both the maxima and minima increase. Intensity of maxima increases and the minima is of zero intensity, and there are other options. Let us see. So we have to find out mostly the intensities of the maxima and minima. Let us see how we can solve. Now see, as you know, when in the interference, in the constructive interference, what happens? The amplitude, they get added up, and the destructive interference and amplitudes, they are subtracted. But now what is said? Now one slit is made twice as wide the other. When one slit is made twice as wide the other, then definitely that intensity will be 2I0 and the other will be I0. So the amplitude will be proportional to the root of this, root of the intensity. So finally, for constructive interference in the second case, we can write I max equals to, if we have to take amplitude, we have to root 2 I0 we have to do, and the other is I0, root I0, right, square, right. From here we can take I0 outside, it will be root 2 plus 1 whole square. Root 2 is 1.4 plus 1, it is 2.4 whole square. Now when I0 into 2.4 whole square, definitely 2.4 square is greater than 2 square, that is 4I0. It should be greater than 4I0. So what happens in the second case? The I maximum, that is the intensity of the brighter fringes, is greater than the intensity of the previous case, right? And what about the destructive interference? For this, for the minima, what will happen? I mean, similarly, root 2I0 minus root I0 whole square. So this will be what? I0 1.4 minus 1. It is somewhat 0.4 I0, which is also greater than 0. So the intensity of the maxima as well as the minima both have increased, right? And hence the answer will be the intensities of both the maxima and the minima increase. Clear? If you see, check the other answers, nothing is correct. The intensity of maxima decreases, minima has zero intensity, no. So this is only the answer. Okay. Let us move on to the next question. I hope we have time. Yes, we have time, right? Okay, let us try to see the last question if possible. Let's try to find it. In the adjacent diagram, CP represents a wavefront, and AO and BP, the corresponding two rays. Find the condition on, it's not Q, it would be theta. Find the condition on theta, that is the angle theta, right? The incident angle for constructive interference at P. Constructive interference is happening at point P. Between the ray BP is this ray, and the reflected ray OP is this ray. OP is this ray. So BP and OP. Let us try to find out. So if you see, as it is a wavefront, it means all the points are at the same phase. So you can think, right, these two sources, if we take this point C and this point P, they are the two sources. They are coherent sources because they have the same phase difference. But we are not finding out the path difference between this C and P. We are finding out between this and the reflected. So the path difference is incorporated because of this path distance, that is CO and OP. So CO, this point has moved extra part what? CO and OP. Right, let us try to find out. So this part is extra. We have to find CO and OP. Right? Let us find out CO first. Let us find out OP first. Let us find out OP. Let us find out OP. OP. OP, say this is D. If this angle is theta, this angle is also theta, right? Now D by OP, D divided by OP equals to cos theta. So OP equals to D by cos theta. Now if you look at CO, if you see from this angle is theta, this angle is also theta. CO by D, CO is nothing but, not D, OP cos of, this is theta, no, not this angle is not theta, sorry, this angle is not theta, this angle is 2 theta, this angle is 2 theta, and this is nothing but OP, and CO is projection of OP. So CO we can say is nothing but OP cos of 2 theta. Now OP is nothing but D by cos theta. So it is D cos 2 theta divided by OP divided by cos theta. Right. Now the path difference is CO plus OP plus lambda by 2 because of this reflection at a higher refractive index surface, right? Now CO equals to D cos 2 theta by cos theta plus it is D by cos theta plus lambda by 2, isn't it? If you calculate, if you take D by cos theta, you will get cos 2 theta plus 1 plus lambda by 2. Now cos 2 theta plus 1, 1 plus cos 2 theta is nothing but 2 cos squared theta, isn't it? So we can write D cos theta 2. So this is the total path difference, right? Now our question is, if we have to find out constructive interference, the path difference will be an integral multiple of lambda. Our path difference we have found 2d cos theta plus lambda by 2. Let us put it. So 2d cos theta plus lambda by 2 equals to n lambda, right? N, right? For n equals to 1, the simplest case is n equals to 1. If you take n equals to 1, so this becomes lambda, we get 2d cos theta plus lambda by 2 equal to lambda. So if it goes this way, it becomes lambda by 2. So 2d cos theta is lambda by, will be lambda by 4t. Clear? Let us explain it once more. So what is happening here? When there are two rays and both the sources, both the points are coherent sources as they are on the same wavefront, this extra path, because of this reflection, we have to find out this path difference that we calculated geometrically, and we have added one extra path difference of lambda by 2 because this ray is getting reflected from a high refractive index surface. And then for constructive interference, we are equating with n lambda. If it is for destructive interference, it will be 2n plus 1 lambda by 2. Okay. So that's all. Thank you for today. Already almost end of the preparation. 1 or 2 classes more. Best of luck. Do well and thank you.